Hi there, and thank you so much for joining me today. We are going to talk all about dilations. So when you think of the word dilate, you may think of the eye doctor when you had your pupils dilated. And what that did was it either made your pupils larger or smaller, but regardless, it still kept your pupils round. So that is exactly what we're going to be talking about today. This morning I made a copy of my hand and I dilated it, but this had a scale factor of 1, so it kept my hand the same size. I also dilated my hand by 1.5, so that made my hand a bit bigger than its actual size, okay? And then I dilated my hand by 1/2. So it made my hand a lot smaller than the actual size. So I'm going to show you what this looks like with shapes and how to do it and what exactly scale factor means. So when you dilate a shape, you need to know 2 things. You need to know 1, what is the scale factor, and you need to know 2, what is the point of center. So let me show you what I mean. Let's pretend the point of center for this one is right here. Your point of center could be anywhere. It could be on one of the vertices of the shape, or it could be in the middle of the shape, or it could just be in a random spot. So what that means is that is the point that the shape is coming from. It's like if your shape is further away from your point of center, it is going to be larger. If your shape is closer to the point of center, it is going to be smaller. So when I think of the word point of center, I think of a flashlight. The light that's coming out of our flashlight is smaller when it's close to the flashlight. And the further the light gets, it gets bigger and bigger and bigger. So that is kind of the same idea when you're dealing with point of center. So the first thing you want to do is draw a line from the center of dilation to each of the vertices in your shape. And I'm actually going to extend my vertices past our shape because I also want to show you what it looks like when our shape gets bigger. Okay. Okay, so now I've drawn a line from my point of center or my point of dilation out through each vertex. It crossed through vertex B, A, and C. So now what I'm going to do is I am going to measure the distance from my point of center to each vertex, and I am going to cut that in half because I am going to dilate this shape by half, which will make it smaller. So that means each side length is going to be half the distance than it was originally, and my shape is going to be half the distance it was from my point of center. So from my point of center to C, it is 10 inches. So now C is only going to be 5 inches away, which is about right here. So this is where my new C is going to be. A is about 7 inches away. So this time my A is going to be 3.5 inches away, or right here. And then point B is 11 inches away. So half of 11 is 5.5. So my new B is going to be right here. My only other step is to connect my vertices to make my triangle. So when you do a dilation, the angles do not change. If this right here was a 90-degree angle, it is going to stay a 90-degree angle. If this right here was a 60-degree angle, that would stay a 60 degrees. So the angles never change when you do a dilation. The only thing that changes for now is our side lengths, And obviously that will change the area and other parts of the shape too. But what I really want you to pay attention to are the side lengths, okay? So this side length is half the distance this used to be. This shape is also closer to our point of dilation. It's half the distance that it was. And then how you label the new points, this is still going to be C, but we usually put a little hash mark above there because then we would know which our original shape was and what our new shape was. So I'm going to label this B with the little hash mark, and I'm going to label this A with the little hash mark. So if a brand new person came and looked at these set of shapes, they would know, oh, this is the original and this is the new one. So now I'm going to show you what it looks like to dilate our original shape by 2. So basically, we are going to double all the side lengths, and we're going to double the distance from our point of center. So originally, from our point of center to C, it was 10. So our new one is going to be 20. So 20 is going to be all the way up here, okay? And then from here to A, it was 7. So our new one is going to be 14, which is right here. And then our B distance was 11. So our new one is going to be 22. All the way over here. Since this is the third version of our shape, I'm going to call this C, and I'm going to put 2 little marks. I'm going to call this A, and I'm going to put 2 little marks. And I'm going to call this B and put 2 little marks. The reason we don't put 3 marks, it's our third version, is because the original one doesn't have any marks. So it's like this is the first new version. This is the second new version. Okay, so I'm just going to connect my vertices to make my shape. And there we have the shape dilated by 2. So if you notice, the side lengths of our shape doubled. They are twice as long, okay? What happened to our ankles? That's right, our ankles did not change. Bonus question, what happened to the area of our shape? Did our area double? Going from here to here or here to here, does the area or the space inside the shape double? What do you think? So if you answered no, that is correct. To find out what happened to the area, you actually take the number you dilated by. So we dilated from this shape to this shape by 2. The scale factor was 2, and you actually square that number. So 2 squared is equal to 4. So the area actually quadrupled, okay? So that is how you do a dilation with a point of center. You basically measure the distance and then you multiply it by whatever the scale factor is. That is how you do dilations. I am going to make another video on how to do them on a coordinate grid. But if that made sense to you, please give me a thumbs up and don't forget to subscribe.